Hi, my name is Clay from OpenC3, and today I'll be showcasing one of our enterprise plugins, which is going to be integrating with the power supply here from Keysight. It is an N6700 power supply here, and I'll be integrating that with COSMOS so we can remotely control everything on this power supply over Ethernet. This is going to be one of our enterprise plugins, so if you are an enterprise customer, you get full access to this plugin among many other plugins that we have going on. So let's start off by talking a little bit about what SCPI is and how we're going to be communicating to this power supply. So the SCPI standard is short for the Standard Commands for Programmable Instrumentation, and it's a standard that provides a common interface language between computers and test instruments. For this example for today, our Keysight N6700 power supply is using the SCPI interface so that we can communicate with it. It's a very popular standard that is used across a variety of programmable instruments, so everything that you'll learn today and everything that you'll use today is going to be well applicable for other types of instrumentation besides this power supply as well. So what we did to integrate with this is that if you actually access the user manual for the N6700 low profile modular power system, you can actually get a very nice command summary of all the different commands that's available to this power supply written out in SCPI. So if you'd like to learn more about it or all the different options, you can definitely check out the user manual to get an understanding of what commands are available to you so that you can have a better control of your power supply. So for today's purposes, these are some, just kind of give you like an idea of how we are commanding this and how the SCPI protocol works. So in this first example, this is going to be a command to set the current to 1.2 amps on channel 1. So this is like the basic syntax of how SCPI works to set something. The question mark is going to indicate that you have, this is a query. So in this case, I am querying, hey, what is the current set to on channels 1 through 4? So this is just an example of how we can query the system to understand what is happening on the system side. And then on this next one's going to be for measured voltage. So maybe what you set it to is going to be different from what is actually measured out. So this is saying, hey, please measure for voltage as a query on channels 1 through 4. Sometimes you don't need to specify a channel. So in this case, it's going to be for the display. If you wanted to change it from the meter 1 to meter 4, where you can look at all 4 channels in one page, or if you want to look at one meter, these sort of system level settings that aren't particular to a channel, you don't need to specify the channel information. And then this last example is one where I'm setting the power limit to 25 watts on channel 1. So this is just a quick overview of how SCPI commands are going to be implemented on COSMOS side so that we know how to send out the commands to the SCPI power supply so that it can understand what we're trying to do and that we can communicate it with it effectively. When you install your plugin, take a look at the system and active settings that you have on your power supply to ensure that the current IP address is going to match the IP address that you are setting on the COSMOS installation. And on the COSMOS side, when you are installing the COSMOS plugin for the SCPI power supply, make sure that the IP address will match the IP address that is reported on your power supply, and adjust either the COSMOS side or the power supply side as needed to ensure that you can get a stable Ethernet connection. I'm going to start off by going over all the different commands that we can send directly from COSMOS to our power supply, and then we can validate those commands and make sure that they went through on the power supply. So let's get started. So first what we have, I'm going to take a look at this packet, the list of packets that we have in Command Center. This is probably the easiest way just to get a glimpse at what commands are available to us that are defined in our plugin. We have information like clear status, the current, display view, get status, the output delay, fall and rises, power setting, reset, and then a direct SCPI commands with no responses or with responses, voltage controls, and voltage slope. So the first packet I'm going to send out is going to be the current. So let's say in this one, current is an amperage. The range is from 0 to 2.55. 2.55 is what is the power supply's range. So anything outside of this range, the power supply is going to send an error to us. So I'm going to, let's say, set it to 0.75 amps to channel 1. So notice right here, we have the statuses that we are retrieving actively. It is currently set to 0.5 amps. So we'll notice that change. We'll send that out. And then on the power supply status, we see that indeed the current was changed to 0.75. The measured voltage, measured current, this power supply is still turned off, so we're not going to see any changes in that. And then let's go to the voltage. So for voltage, this one is currently set to 0.03. The range is from 0 to 20.4. Again, that's the range on the power supply. So anything outside of that range, it's going to give us an error. I'm going to set this to, let's say, 1.2 volts. And some of these numbers are kind of arbitrary that I'm choosing right now because I'm not necessarily outputting it to an actual device. So I'm going to send this out. And then in our next update, we'll see that the status is now set to 1.2 is our set voltage. Wonderful. There's a whole lot of other packets that we can look at here. So let's take a look at that. So let's take a look at voltage slew. I'm going to change this. This is the rate of voltage changing. So I'm going to change this to, let's say, 50 volts per second. I'm going to send that out. And then we'll verify all of these, that make sure they all went through on the power supply itself. We'll go to the power, so we can set the maximum power limit. I believe the default is 50 and 0 to 50 is the range. So let's say we want to max it out at 25 watts. We're sending that out. Let's take a look at the output delay, fall and rise. So this is the turn off delay. The range is from 0 to 1.023 seconds. So I'm just going to set the fall to 0.5 and the rise 0.75. And then lastly, let's turn this thing on. So we have 4 channels on this power supply. We have, the mainframe has slots for 4 slots, and then we have all 4 slots occupied with the N6700B. So I'm going to turn channel 1 on. Boom. So then now we will see this screen now updated. We are now actually measuring near 1.2 volts now that it's actually turned on. All the other ones are still turned off, so the voltage measured is going to be still near 0. And then this one that's actually turned on, it's actually now reporting some voltage. To validate everything that we just said, we can take a look at what's actually reported on the power supply. So right now we are set to 1.2 volts and 0.75 amps. We can take a look at the menu, other metrics that we have defined. So in our output, we can take a look at the voltage, 1.2, the current, 0.75, the delay, the turn on delay at 0.75, turn off delay at 0.5, the voltage slew set to 50 volts per second, and the power set to 25 watts. At this point, we can take a quick look at the display. So right now, the display view is going to be set to meter 1. Meter 1 is kind of the display where we just get one power supply's information at a time. You can also choose meter 4 to get all 4 at a time. So I'm going to send that out. And then if we want to switch it back to meter 1, we can just send it directly from here. With meter 4 set as our display, we can take a look at all 4 of the channels all in one place. So this provides a much more concise view to get an idea of how our power supply is overall performing. So that's a great overview into all the different commands that we have pre-packaged with the plugin. So these are all ready to go. But if there's anything that's not defined that you want to send direct SCPI commands to, that's something we can do. So we have 2 set up here, SCPI no response and SCPI with response. The no response is going to be for things where no response is expected. So these are going to be non-queries. It's going to be something like an action, like setting something. So the example we have here is, hey, I just want to set the display view to meter 1. That's not going to require a response. It's going to be a very quick send out there. So we can set that up. So I can send out disp view meter 4. And that'll go out as a direct SCPI command. So this is a great way if there's any types of SCPI commands that you want that is not already in our plugins and you don't necessarily want to write out the command lm database for, this is something that's great where you can just make a direct call to our power supply. The other example is SCPI with response. So let's say you do want a response back. You do want to know what it is. So maybe you're querying for the voltage. Maybe you're querying for the current. And the example I have here is just, hey, like what is the current display? So I can send that out as a query. So the question mark is going to be indicating that it's a query. I send this out. And on the right side, we'll see that the pass-through response from this command was meter 4. That's just going to always track the latest response that we got from the SCPI with response. So you might be wondering, hey, what is this system error queue response and what does that detail? What do you do when these commands to the power supply fail? Well, how the power supply tracks errors is that there is a queue of errors that are building up. And as part of our get status packet that is commanding to retrieve the status of the power supply, we are also querying for the error. And if there are any errors reported back, and if there's no error, it's just going to say +0, no error. But if there is an error, it gets popped off from the queue from the power supply and then added as a sub packet into Cosmos. So then that's a great way for you to look at the different errors that might be happening. And we are always going to be showing the latest error that occurred if there is any reported. So with our commands that we already have, it's going to be a little bit tricky to trigger an error because these packets are well structured and they're not going to error out. But if you want to do a direct pass-through, that's a quick way to trigger an error. So let's use the SCPI no response, and I'm going to send out like this will fail. So this is a direct SCPI command, but obviously this command does not exist. So when I send this out, I'm going to receive this. So boom, program mnemonic too long. So this is a great way to get all the different error messages that's happening and get a quick validation of what might be happening. So obviously that was going to fail. That was never going to work. So let's say we are trying something and there's like some kind of legitimate error that might be happening. So maybe that is current. I want to set the current to 100, which is going to be out of range of channel 1. So I'm going to try to send that out and see what happens. And we get a new error message back. So the message is channel 1 range is 0 to 2.55. And that is the exact range that we have the amperage packet, the current packet set to, so that when you are sending regular Cosmos-based commands, you can't hit that error because it's always going to be doing that range check to make sure that you are within bounds before that command even leaves Cosmos. So that's a great way to test that. So now we had a range issue, or maybe there is like a mnemonic that doesn't exist, or maybe you had a typo. So like maybe you are like, this is pretty close, but not quite what we wanted. So we'll send that out. Boom, undefined header. So this is a great way to get all the different system error responses that's happening if you're sending these direct packets, or if there's any sort of other anomalies that may be occurring, you can get that detail right there. So let's jump into screens. The screens are going to be the main UI kind of custom area where Cosmos really shines. This is where you can define custom screens that are going to be integrated for your hardware so that you can define all the different buttons and displays and mnemonics that you want to show so that all the information you need is in your fingertips. So we have a variety of screens that we have predefined as part of this plugin. We have the control control screen, which is going to give you like all the information to sufficiently control your power supply. So this is going to be a lot easier than sending out individual command. I can turn on channel 2. I can set the voltage on channel 2 to 2 volts. I can turn off channel 1. I can set the current on channel 3 to be 5 amps. Actually, that's not going to work. 2 amps. All these things can be set directly from this screen, and it's going to be a much faster interface to be able to integrate well. All the different range checking, all the different errors handling, all that still exists. So if I wanted to set the current here to 50 amps, if I hit send, I get the error here because that's going to be out of the range check for us. So all those safeties and securities are still there, and you can look at if the channels are on, the measurements that they're reporting, the set points, what we actually set the voltage and amperage to, and then the controls to do those things. This screen is going to be for graphs. So graphs are going to be a great way to look at all the different trending voltages and current numbers that you're observing from your power supply. Up top here, we are able to see the output, if it's on or off, the measured voltage and measured current in real time, and then the voltage and current information for the last 2 minutes. If any of this needs to be edited, or if you want to modify it for your own needs, you can always hit that edit icon and then change these details to however you see fit. You can refer to docs.openc3.com to take a look at how you can configure these screens so that you can get all your information all in one place. And then, of course, you can flip through the pages and take a look at all the different current and voltage information that we are outputting from our power supply. Next screen is going to be our status. So this is just going to be our general status information. If you just want to look at the measured current, set voltage, measured voltage, without the ability to control anything, you don't want to touch anything, you don't want to actually change anything. This is a great interface so that you can have no buttons, but just a display, kind of a read-only view. Thank you so much for watching this video. If you're an existing enterprise customer and if you have questions about this plugin or any questions about this about the SCPI Power Supply plugin, let us know on GitHub as an issue. And if you're interested in getting access to this among other of the many plugins that we offer as part of our enterprise solution, let us know at sales@openc3.com. Otherwise, thank you so much for watching, and we'll see you next time.